Let's go ahead and get started then. So SQL Server Admin Best Practices with DMVs. This is an incomplete tour of SQL Server Dynamic or DMVs. I want to spoil my own joke. Recovering the most important topics and getting started on getting you the most out of these crucial performance indicators. Can't read today. Okay, so audience for this, it is an intro level presentation. We are going to cover some fairly advanced stuff, so I think this is good for everybody. I've presented this a lot of times at SQL Saturday over the past decade or so. So devs, sysadmins, BI analysts, data scientists, DBAs, everybody of all levels of experience probably going to get something from this presentation. The purpose of this presentation is not to give you an inventory of all the DMVs that there are in SQL Server. Here are the most useful and the most popular and the ones that appeal most to our need to do best practices when we're administering a SQL Server. Getting anything out of these DMVs is going to require you to try them yourself. A lot of the times, if you're looking at the output of this DMV on a dev or a test environment, it's not going to be very useful to you. Short, quick-hitting labs throughout. We won't go through all the labs. I'm going to mention a lot of scripts in the labs, but just for timing purposes, it's not going to work out today. I'm going to do one lab, but all the other labs that are referenced are going to be in a toolbox that is available for you, and I'll give you the link for that. So again, I encourage you to take these DMVs. If you're not already looking at some of these things, look at them on your servers. Understand what they mean for your production environment at maximum utilization. Understand what they mean for your environment when it's quiet, and then track and trend those things over time. So don't worry, all the slides and samples are going to be posted at my blog. Some of the labs are going to use the Microsoft Wide World Importer sample database, which is available for download there. And all of the lab scripts, any of the toolbox.sql scripts that I talk about are going to be right here on GitHub, and I'm going to include all those links for download as well. So what is a DMV? Is it the Department of Motor Vehicles? And us in the United States, we know exactly what this is. I'm sure it has other names everywhere around the country, and it is as reviled everywhere around the world. Is it the DMV proxy service? A brilliant idea. Is it the Department of Motor Vehicles Metamusical with just one of the blue men? Just one of the blue men? No, it is not that. Is it the DMZ? No, it is not that. Is it Run DMC? No, DMZ. The DC, Maryland, Virginia rap scene? No. DMB? No, that's DMB. I'm talking about DMVs, dynamic management views, are in place to provide system transparency. The DMVs we're talking about today are the foundation of countless third-party SQL monitoring applications. They all fall into a category of DMOs, or dynamic management objects. Some of these are DMFs, table-valued functions with parameters. For this presentation, I call them all DMVs because I can make more jokes about DMVs. Most of the DMOs in this session work at least partially, perhaps not all the columns are included, but at least partially back to SQL 2005, database compatibility level 90 in each database. Some database level DMVs require the database to be in that compatibility mode or higher. Some included toward the end of this presentation have been introduced more recently, including some we're going to go over today that have been introduced in the upcoming SQL 2019 release. Often DMV changes are pushed to older versions via service pack, so it might not have worked in RTM for SQL 2012, for example, but it might have been pushed into service pack 4 for SQL 2012. We're going to look at one of those. Most of the content applies to SQL Server, Azure SQL, SQL Server on Linux, and the Azure SQL MI. So not all, but most of them apply to regardless of what SQL platform you are working on. Let's talk about permissions. Most DMVs require only view server state or views database state, and you can grant them with this permission script here. There are no data permissions that are involved here, and so these may be appropriate even for developers in your production environment. Obviously, your regulatory environment may change. So let's get started. First thing we're going to look at is WeightStats. These are aggregated wait times. It records when something has a wait and retains that information. It records the count of tasks experiencing the wait type as well and the amount of time they waited. There are over 1,000, more or less, documented wait types in SQL Server 2019 RC1, an increase of 7 wait types just from the CTP 3.2. So they are adding these wait types a lot over the time. There have always been hundreds of them, but the ones that we're going to talk about today are the ones most important. WeightStats can be powerful diagnostic tools, and so many performance suits, never noticed that. Suites do little more than incorporate the WeightStats data for charting in their dashboards. But these third-party tools are great sponsors of user groups and SQL Saturday events and GroupBy events, so let's not dismiss those. But they don't have magical access to the SQL Server, right? They have access to these same DMVs that we do, that you as a sysadmin do. So on-demand task queue, let's go over a few of these that you don't need to care about. High wait times of this type indicate lots of idle time. You can ignore or disregard this wait type. There are actually many innocuous wait types that are of no concern for you. Here's a list of some, and SQL Skills blog, Paul has a really good list of ones that you really don't need to worry about. They have been documented, they are innocuous, you don't need to worry about them. You're gonna see a lot of these on your laptop where there's no workload. Let's talk about some of the ones that you do want to care about. And if you were in Bob's presentation, which was excellent right before mine, you probably already heard about locking. So the lock M, and there's a lot of different type of lock M weights. These reference locking. This, if it is very high, or if this weight type is trending upwards in your production environment, which again, you should be tracking and trending those kind of things. This is a sign of transaction lock contention. Go watch Bob's presentation from the last hour. You can learn all about that. This could be a sign of poor queries, poor indexing, causing too many scans and execution plans, for example. Maybe a new non-clustered index seek could relieve that pressure. Synchronous availability group replicas will also increase this weight. So, and again, like Bob said in the last hour, if you have a lot of these locked, consider RCSI, the recommitted snapshot isolation. That is the enterprise solution for concurrency introduced in SQL 2005. And stop adding no lock to your queries. It is dangerous. CX packet. This is a clear indication of excessive execution plan parallelism, and CPU is struggling to keep up. A lot of servers out there, CX packet is the #1 weight type. Is that necessarily a problem? No. Does it mean that we should try adjusting some dials to see if we can get more performance? Yeah. So the two dials that you want to adjust are the max degree of parallelism and the cost threshold for parallelism. And by default, these allow for a lot of parallelism, even with the new installer options for SQL 2019, providing a recommended max stop equal to half the number of processors, which is great. And there's some other rules about that. It's not strictly a half. This is great, but you may want to consider turning down the max degree of parallelism and turning up the cost threshold of parallelism. What I'd recommend is you do these in gradual steps where you are monitoring your performance for key queries and key operations throughout. So max stop can be configured server-wide. In recent versions of SQL Server, you can do this at the database level, and you can always do it with an option max stop at a query level as well. Enforcing max stop is also one of the best uses of the resource governor, an enterprise-only feature where you can enforce max stop based on certain connections as they arrive into your SQL Server. So SQL Server 2017 CU3 and 2019 introduced a split. CX packets is actually now split between CX packet and CX consumer. Before, CX packet would be incurred by both threads that consume and produce data in the query plan. We're not getting too complicated here, but what you need to understand is that CX packet actually has been lowered because some of what used to be CX packet is now going to be in CX consumer. What is in CX packet is actually more actionable for you as an administrator, as someone who is tuning queries and helping with indexes. And so it's actually going to respond more. CX packet is going to respond more to your troubleshooting steps. This is a good thing. But just realize that after that CU3 for 2017 and then in 2019, CX packet will be lower, and you will see a new one called CX consumer. SOS scheduler yield. This is a clear indication of CPU pressure when this is the highest weight type. There are too many running tasks for the available threads. SQL stopped an operation and yielded to another task. Increasing the CPU, hiding it with iron is the simplest, but also the most difficult and expensive solution here. Look for and reduce CPU intense queries. We're going to discuss more about that later, both with looking at cached execution plans and looking in the query store in SQL 2016 and above. OLADB describes weights associated with external communication. There's a lot of people probably who have seen this around because this is commonly caused, it can be caused by SSIS, but it can be caused by Microsoft Office applications. So somebody over in marketing is trying to bring down the entire database into their Access or to their Excel file. This is going to show that. It's also going to show another weight type as well. It could also be generated by internal commands like dbcc checkdb, so it's not always an external problem. Resource semaphore. So request is waiting on memory to be gathered before starting. This is an indication of memory pressure caused by obviously less memory, but instead of hiding it with iron, go look at your query design, go look at your indexing, go look at your most expensive execution plans and tune those. Almost through with the ones you do need to care about. Page latch and page IO latch on the same page, but they have nothing to do with each other, and I want to make sure we understand the difference. Page latch has nothing to do with physical IO, the storage system, hard disks and volumes and SANs and stuff like that. Page latch is multiple threads attempting to access a page in memory. So this is contention over a page in memory. It could be tempdb temp tables that are being overused, or it could be an insert statement generating a hotspot on a table. We're going to actually talk about a couple solutions for that. Page IO latch, on the other hand, this is physical IO. This is reading data from a disk into memory. So hard disks and SANs are struggling to keep up with whatever it is that you're asking them to do. Often this is because not a SAN problem, but again, inefficient application code, poor indexing, poor queries. Or again, the goons over in marketing are running an access and pulling down entire tables. This could be one of those as well. I blame a lot on the marketing folks. Page latch, for new in SQL 2019, there is an index option called Optimize for Sequential Key. When you get onto 2019, definitely look for this. Because if you're like me, my table pattern starts with an identity column or a sequence column, depending on the need, but an identity column that is the primary key clustered index of the table. And as a result, you have rapid writes that don't create fragmentation, but for very high scale could create hotspots where that write is competing for the same page with other writes. If you observe high amounts of page latch exclusive, the EX type, it may be because of this contention for pages in memory, and there is that new index option, Optimize for Sequential Key, that can help reduce this. There's a link there, and there's lots more information online, but this is coming, and this is definitely something I'm going to be putting on a lot of my tables using that default pattern. Another new feature in SQL 2019 that is coming, if you see a lot of page latch weights that are encountered on tempdb system resources, and you can always look and see, especially in the sessions and requests, which we're going to look at later, you can see what weight is incurring, what resource is incurring that weight. If you see a lot of these type of weights on tempdb system resources, a new feature of SQL 2019 may improve performance, and it's called memory optimized tempdb metadata. And this option improves tables containing, moves tables containing tempdb metadata into non-durable memory optimized tables. Non-durable being, of course, completely appropriate because it's tempdb. So no more latches, no more hotspots in tempdb pages for internal metadata. This could unlock a lot of performance for you. Okay, moving on. ASIC Network IO. Now, this is the one the marketing people really do. This is very common. It's caused by weights involving the reception of data by remote clients. And it could involve the processing of that data by the remote client, but more likely it is the transmission and the reception and the calling of that data by the remote client. This is almost certainly not caused by the network. It is not the fault of the network team, a switch, a cable somewhere, almost certainly not. It is almost certainly caused by poor queries like select stars without a where clause, like Access loves to do with a global linked table. So look for queries with very high row counts to explain why ASIC Network IO may be very high. So when do you want to analyze WeightStats? You want to analyze on healthy or on troubled systems. Look for trending from a baseline. Determine which weights are impacting the performance server-wide, and this is one of the best DMVs to look at for SQL-specific server-wide performance. This number is forever growing, that is returned by the query, which means over time, if you're just looking at the whole thing, recent changes will not affect the large aggregate very well. So for your performance-sensitive servers, which should be most of your production servers, consider a regimen of collection and manual wiping of the stats weekly or daily, or a regimen of collection and snapshotting those data and then doing some math on the differences between those snapshots in order to determine how much weights were actually incurred in the last day or the last week. Either of those two approaches can work pretty well. And there's a lab you can test for yourself on your home, on your production servers, of course, using a script right there that's going to be in the toolbox, and I'll explain the toolbox link later on. So again, DMOS WeightStats is aggregated at the instance level. It doesn't include live data. It doesn't include request or session level data. For that, you'll need the next DMV, and that, ladies and gentlemen, was a segue. DMOS weighting tasks shows weights for current requests, not aggregated. So it's not much different from the current weight information you can get in DM exec requests, and more on that important DMV later on. This shows weights for the current session. The new one, DM exec session weights. Instead of server-wide weights or current weights, we can drill into specific query weights associated with a session so far and all the requests that that session has made since it connected. This syntax is the same as the aggregated WeightStats, but it includes an extra column for that session ID. And this could all be pretty useful. So again, when you're looking for WeightStats, here's a summary of them. The first one is aggregate WeightStats at the whole server level. The second, weighting tasks, is live session level weights, but you have to catch it running. And then DM exec session WeightStats is aggregate session level weights for the entire session's connections so far. Let's move on. Sys.DM exec query stats. So this sorts performance about the cached query plans in memory. But rows do not persist after the plan is removed from cache, or obviously after an instance restart removes everything from cache. It provides a SQL handle and offsets, which are integers, to identify the statement within a batch. So for example, if you have a large stored procedure that does many different statements, you can use the SQL handle to identify the plan and the offsets to identify where literally the characters begin and end for the statement that you're using. And so then you could tell which part of my very long stored procedure is most problematic. You get one row per query statement within the cached plan. So use this for in-depth performance tuning. Find the worst queries. I'm doing air quotes right there. I should have kept my video on. Doing the worst queries in terms of total worker time, rows affected, duration, for example. It records total writes, total reads, and can be used in summary to measure activity and really define the hot spots and the worst queries in your database. But wait, if you're thinking this sounds familiar to Query Store, you're right. So worst query plans.sql is something that's been in my toolbox for a very long time, but since 2016, on 2016 and above servers, the Query Store has this feature and much more. Not only does it have a UI, which is pretty useful, and it has a whole bunch of DMVs in the background, which are very useful as well inside the Query Store. Now, I actually I don't recommend, rather, using the worst query plan script anymore based on DM exec query stats. I did want to show this, but I want you to understand the Query Store is great. It's not enabled by default, though. So in 2016 and higher, go enable that, and you can get the same purpose of what I've been talking about as far as trying to identify, all right, what's the worst query plans? And you can even, thanks to Query Store and the way it archives data, look and see, hey, what was the worst query plan at 2 o'clock, 3 o'clock today? And then you can see all sorts of information about those queries like a black box recorder. And it's not limited by the procedure cache. So that Query Store, new in 16, starting in 2017, the Query Store also tracks the weight stats, the first thing that we talked about too. It tracks the performance of queries, not just of the execution plans. And that is a really distinct difference. If you haven't already heard the Query Store's sales pitch, and this is not a Query Store presentation, understand that the Query Store can detect when a query has suffered degradation in performance because its query plan changed. So you're actually getting data at the query level, not just at the plan level. While the worst plans in cache had that strategy to identify the most expensive plans, the Query Store is a step better, finding the worst queries regardless of their plan, and even showing a history of queries and their plans. And this is highly recommended when doing performance tuning. So the next logical step is, so what if a SQL server could use information about regressed queries, queries that used to run faster, and a history of execution plans to decision automatically to use a better plan? So now it can. In SQL 2017, there's this feature called automatic plan correction. Azure SQL Database actually already does this for you. Automatic plan tuning is based on the Query Store. It's available in Azure SQL always, and it now in SQL 2017 to revert a query from a newer, slower plan to an older, faster plan. You can accomplish this manually yourself, or query the underlying information yourself with a host of DMVs, including a DMV called DMDB tuning recommendations, and there's more about that there. But I'd recommend turning on both the Query Store and automatic plan correction. They are not enabled by default in SQL 2016 and 17. Again, automatic plan correction works. That's the statement to turn it on. It will automatically force any recommendation where the estimated CPU gain of total duration is higher than 10 seconds. Okay, let me pause for a questions break there. Anything up so far?
For now, it looks like we're good on questions, actually. I don't
right.
see anything popping up. Everyone's just making lots of fun DMV puns.
Love it. All right. We're making good time, so let's keep going. All right. DM exec sessions. So this is queryable session information. It includes connection identification information. It replaces the old system view, and I know I'm dating myself here, sys.sys processes. And it is often joined to DM exec requests, which is why I said sessions and requests earlier. This is a go-to query for us. So it shows current activity like SP-Who2 active used to, but it only shows the active requests. So again, connection is a session. Object Explorer in Management Studio. Each tab in Management Studio is a session, right? A request is when actually you're doing something, when something is actually executing. So DM exec requests shows only the active requests. This is the main hub for many other dynamic management objects as well, providing request info often joined with other dynamic management objects. It also provides a SQL handle and offsets that we talked about before to identify the statement within a batch or stored procedure. So you can put together sessions and requests for a query status that's far more detailed than SP-Who. And a lot of people have written their own SP-Who2 replacements based on these two DMVs. And one of the reasons I wrote my own a few years ago, back in 2011, as you could see, sessions and requests query was that I had some huge blocking chains at a client site. Turned out to be huge SSRS reports that were just hanging and going wild. And so when you look at just SP-Who2, or when you look at just the blocked by column that you see at the end right there, it's hard to know what may be at the root of a blocking chain, right? Of all these queries that are blocking each other from executing. And so what I used sessions and requests for was to build a comma delimited list of all the queries that a query, all the other sessions that a request is blocking. So as you can see right here in row 1, session 623 turned out to be our culprit. It is blocking all of those other sessions in the blocking these column, and this result set is by default ordered by the length of the blocking these column descending. So as you can see, if you were looking just at the blocked by column, 623, 137, 533, was a whole bunch of 533s there, which of these sessions that are all SSRS reports should I go and kill? And it might have been just kind of a guess. Well, now I kind of know. Not only is 623 having the longest blocking these lists, but you can see it's blocked by 0. It's not being blocked. It's just running. You could also see that in the status as well. And you can see 623 was blocking 137. 137 was blocking all of those other ones, including 533. 533 was blocking a shorter list, and so forth and so on. So, 8 years ago when I did this, 8 years ago, almost to the day. How about that? 8 years ago when I did this, kill 623, and everything just cleared up. Everything completed, and we were on our way. Would have had to guess, would have had to kill a bunch of unnecessary sessions if I hadn't been looking at this. These are the kind of cool things you can do with DM exec sessions, DM exec requests. So use also the helpful %complete column in DM exec requests to check the progress of a backup or a restore operation or a DVCC check DB operation. It really is a progress bar. And so based on the start time value of the request, because the DM exec request has a start time for when the request started, and the progress bar, you can even estimate a completion time as well. So even if someone else started a backup or a restore and you're not looking at their UI to do that, or you're not looking at their Management Studio query or the tool that is running the backup, you can actually see a progress bar and an estimated complete time for any one of those 3 operations using that %complete column in DM exec requests. And there's a lab right there you can demonstrate for yourself. Moving on, DM exec input buffer, aptly named because it replaces the old DBCC input buffer to an extent. DBCC input buffer is still not deprecated according to the documentation, but it has been effectively replaced by this one. This can display the last command issued from a session, even if there's no live requests. So it's literally what's in the buffer. It does behave a little differently though, inside of a trigger from what I understand. And that's why the old DBCC input buffer has not been replaced, because it's not been replaced perfectly for its behavior by the new DMF. So some indexing DMVs you should know. We're going to go into in-depth of each one of these. We're going to talk about physical stats DMVs. These help you evaluate for index maintenance and what needs index maintenance. Missing index DMVs helps you evaluate what indexes need to be created based on passively collected data. And index usage stats, which helps you evaluate existing indexes and whether or not they're worth keeping around. So let's dive into each one of these sections now. So DB, index physical stats, determines the index fragmentation to do SQL level defrag. This is the root of all index fragmentation monitoring queries, monitoring suites, defrag tools, or anything like that. Average fragmentation in percent shows the logical fragmentation for indexes and extent fragmentation for heaps. We're going to talk about why that's not necessarily helpful. And so this DMV, or DMF rather, replaces the functionality of DBCC show config to an extent. That's upon extent 8 AK pages. We'll move on. This will still show tables. It's hard to get a laugh track from a webinar. We'll still show tables without clustered indexes in this DMV as index ID equals 0. Well, this is a heap. And almost always, I would argue, and I can argue if you'd like, almost always a heap is poor design or an oversight. However, you will show you index ID equals 1. That's the clustered index. And index ID 2 or greater, that is every other index. So if you see a lot of stuff with a heap, not only is this DMV not helping you because a heap doesn't really have a meaningful sense of fragmentation, but a heap is probably not going to perform that well when you try to read out of it. Average fragmentation in percent is a scale of 0 to 100. 0 means not fragmented. You'll probably never see that. To 100, which is perfectly fragmented, you'll probably see a lot of 99.99s. You may find it beneficial to perform some sort of index maintenance when you see average fragmentation in percent is greater than 10. That's what's in the documentation for Microsoft, so I kind of have to say that. But in my experience, it's usually higher where you actually see some ROI on the time spent doing index defragmentation. So this may vary for you. You may find a better balance of meaningful performance protection and logged maintenance activity, and certainly time, with a less aggressive maintenance threshold of maybe 50% fragmentation. Some things for old DBAs. Alter index reorganize replaces DBCC index defrag. Don't use that anymore. Alter index rebuild replaces DBCC DB reindex. It also updates the statistics. Important to note the biggest difference between reorganize and rebuild. First off, rebuild is disruptive potentially unless you use the online keyword. This is not news to anybody, I'm sure. But also rebuild updates the statistics for that table. So a reorg does not. So a reorg and an update stats or a rebuild is what you should be doing whenever you encounter fragmentation. You can also issue an alter index rebuild all. Replaces all the rebuilds rather, all the indexes on the table, also updates the statistics, but it's not recommended because you should be doing more granular index maintenance. So you should be doing this while your application is in production to identify tables that are generating fragmentation over time, and then only perform index maintenance on individual indexes as needed. And then potentially only on the partition of indexes if you have partition tables. So ideally, defrag the most fragmented indexes or index partitions every maintenance window. Take the top off the stack. And if you're like most businesses that have some downtime in the middle of the night, obviously there's a lot of 24/7 operations out there like hospitals, but if you have some downtime in the middle of the night, you try to take the top off of the stack of fragmented indexes or index partitions. So your custom scripts or however you end up doing your index maintenance should take a selective approach where you're doing index maintenance not in one big block on a Saturday, but regularly throughout the week. One, this decreases the shock hit to your transaction log of all that logged activity. And two, it's going to help with performance if you take advantage of more index maintenance windows than just end of week or end of month. Maintenance plans in Management Studio, I know we're much maligned, but since SQL 2016, they have dramatically increased in their capability to perform complex, conditional index maintenance operations. So you can configure your reorgs and your rebuilds to maintain only the indexes filtered by a percentage of fragmentation level or a page count. So for example, in 2014 on the left here, that's the rebuild index task you had in maintenance plans inside of Management Studio. And you'll notice there's no selectivity there. You're doing the entire database's indexes. You're rebuilding the entire databases, and that does not scale at all, right? You will run out of time. You will fill up a lot of T-log space doing that unnecessary index maintenance, where on the right you see, since 2017, look at the bottom there. You have all these options as to which indexes you want to maintain. You can ignore indexes that are too small. I don't really care if an index has 10 rows in it or 100 pages of data in it. Doing index fragmentation reduction on that's probably not really going to be worth my time. Or you can even do a filter on whether or not the index has been used in a certain amount of time. And this way you can do a very selective rolling strategy of index maintenance each night if possible. So more on this DMV, some mode parameters. So the very last parameter in this DMF, rather, is the scan depth. And so by default, it just does limited, which is the fastest because it only scans parent level pages, not leaf level pages in the B tree. It only returns basic metrics and it leaves the most of the rest null, but you do get that average fragmentation in percent. You do get the most important column. So this is what you should be doing most of the time. Keep in mind though, and while these other options will hammer your disk IO, will cause a noticeable drop in performance if you run these in your production server during the day, even the limited mode can still impact performance. So be aware, you should really only do index maintenance at night anyway. You should really only be checking for fragmentation at night outside of peak usage hours for your production databases. Be aware that this DMV, unlike basically every other DMV in this presentation and most other DMVs, period, this DMV can actually have an impact on your server when you run it. Everything else is generally just looking at metadata. So here's a lab, and I'm actually going to do this lab because it's really good and it demonstrates another thing that I always like to talk about. And so I have a table here that I'm going to create. Nope, this one. Table here I'm going to create, just going to create a primary key on it. It's got 2 columns in it, and then I'm going to put 131,000 records in it real quick. Done. And then just for fun, I'm going to go ahead and remove these other 2, and I'm kind of spoiling my lab here. But I'm going to go over to my defrag, and I'm going to see what is my fragmentation level of the table that I just created, and I just put 131,000 records in there. And see, here we are. Here's my fragmented table query. And this is a query from our own toolbox that we use a lot, and you can see it automatically scripts out the reorg and update stats command or the rebuild command. And this is helpful. This isn't automated. This would be something if you're doing manually. Obviously, our automated script is a little more sophisticated than this, but it scripts out the commands for you. It's kind of helpful. So you can see that it scripted out a command to do an index reorg and a rebuild for me, and my fragmentation level is 94%. That's right, my fragmentation level is 94%, and something in your spider sense, something, if you chose that as your superpower, in the back of your head is pinging you that, William, you just inserted 131,000 records. How did you get almost perfect fragmentation out of 131 records inserts? You didn't do any updates, you didn't do any deletes. Why was it so fragmented? And so if you notice, if you were careful, you notice that my ID column, not really an ID column, but the clustered index key that I had was a unique identifier, a perfectly random 16-byte string alphanumeric, right? By putting my clustered index key on a random string, and I'm doing hand motions here, but the first index, the first row, the second row, the third row, all just kind of hop around on each other, creating fragmentation as they're inserted. Instead, let's follow the pattern that I mentioned that I do all the time. An ID column that is an identity integer column, and that's the key of my index. I'm going to go ahead and run this. 131,000 records, there we go. I'm going to go look at the fragmentation level for this, and you can see for the table with an integer column, my fragmentation level is 4. Not fragmented. Every row went in right after the next one, right? I was not fragmenting my table upon insertion, okay? And so you see the fragmentation level there. You can see even the page count is lower to store the same amount of data, basically, 16 bytes versus a 4-byte integer. But then you say, well, William, I love GWIDs, and I use this new sequential ID thing a lot, right? And so I do new sequential ID, which means that my GWID is sequential. A sequentially generated random string, which one doesn't make a whole lot of sense to me, but is not going to create that fragmentation by default. And I say, sure, all right. I will argue about GWIDs otherwise, but you'll notice that my fragmentation level is still pretty high, and it's right on par. So I have kind of solved the problem, but I'm still storing a 16-byte string. And in fact, a lot of times when I do this, let me do it again just for fun. A lot of times when I do this, the fragmentation levels for the GWID are actually higher, and they're not, just because of demo daemons. Right now, they're not. As you can see, you have kind of fixed the problem, but there are other problems with the new sequential ID, including the fact that whenever you restart the server or fail over to another instance, that sequence restarts. And so before you know it, you could eventually be having the same problem where you're causing page splits and fragmentation upon insertion in your table with a unique identifier as the clustered key. Okay, cool lab. And you could do that at home. You could do that on your production servers. You could do it in parties and press your friends just to show the fragmentation upon insertion. Now, leading question. Does anybody remember why the Windows 7 release candidate download page broke? It's because behind the scenes, there was a SQL table keeping track of all the stuff, and Microsoft had a unique identifier as the clustered index of a table, and Paul Randall did a whole blog post about that. Just an example of an ANSI pattern on display inside Microsoft.com that we all should learn from at this point. It was Windows 7. You'd think we all learned the lesson by now. Okay, any questions?
So there was one
Sure.
a good while back. So this was back when you were talking about page IO, Latch, and access and,
Oh, wow, okay.
and Excel. Yeah, sorry. The question the person had is, would Power BI also fall under that category? Do you know?
Yeah, so that depends on how you're using Power BI.
Yeah.
That gets complicated because Power BI can pre-cache a lot of that data. I would say this when you're refreshing the Power BI, or when the gateway is in use, pulling that data up into the cloud as part of the model for Power BI. Yes, and I've seen that happen. Absolutely. But usually when you're just playing around with Power BI, when you have the snapshot of data in front of you, no, because it's not using SQL Server resources at that point. Well, I guess it depends on how you've configured the data connection as well. So yeah, potentially anything could use, anything can cause page latches, of course,
Gotcha.
unless you're using in-memory tables or the memory optimized tables that were introduced.
Okay, awesome. Yeah, I think that's all the questions right now.
All right, we'll keep rolling. So it's a long one. DMDB column store row group physical stats. It's the same thing as the fragmentation stats, the DMV that we talked about before, but this is for column store indexes. Before we were just talking about row store indexes, so clustered and non-clustered indexes that you're used to. Column store indexes introduced in 2012, super awesome now that it's 2016 and above, have their own DMV for that status and their own fragmentation. And you can include this, and you should include this on any maintenance plans that you have for removing fragmentation in your database, because column store indexes need their own. You may find it necessary to actually reorganize a column store index multiple times. And when you look at this DMV, you will see this. Before, the row groups are all compressed and the Delta store row groups are moved to tombstone status. That's the way that column store indexes became read-writable in 2016, as it uses these Delta stores and tombstones. You're going to need to potentially do reorgs multiple times to get it fully taken care of. And you'll see that as you do a reorganize step. And by the way, you only do reorganize steps for a column store. You don't need to do rebuilds. You can, you just don't need to. Reorganize step does the job. You will notice in this DMV, as you do the reorg, it's going to keep changing until it stops changing. I have found that the magic number is usually 2 or 3 reorgs to get a column store index into place and have its fragmentation reduced. Okay, moving on to missing indexes. This was my favorite feature that was introduced by SQL 2005. This is a set of DMVs that record whenever a query plan recognized the need for an index that could have helped performance. The best example of this is when you have an index scan and SQL automatically identifies that, hey, I could have turned this into an index seek if only you had given me a non-clustered index on these columns, including these columns. So SQL is automatically recording that recognized need, along with estimated statistics for the cost and the improvement percentage of that new index. And it's doing this for you already, and it's been doing it since SQL 2005. So there's 3 DMVs here. You join them all together. It's passive. It's already running. This doesn't need to be enabled. And this is cleared out when the server is rebooted. It's also important to note, you can't get old data out of a missing index suggestion because it's cleared out for a table whenever you alter that table or alter its indexes, because that could also be altering the usage, obviously. So it knows to wipe the suggestions for that table upon alter. And it only recommends non-clustered indexes. And so it doesn't recommend a column store, a clustered index, obviously. You have to design that. And it won't recommend the column store index. In fact, if you have column stores in use, remember the missing indexes DMVs go back to 2005. You kind of have to use them with sobriety. They could actually recommend a new non-clustered index where a column store is working just fine now, right? So be aware of that. Missing indexes views and the suggestions that come out of them must be used with sobriety. Do not create every suggested missing index, or your inserts, your updates, your deletes, your writes will suffer. Non-clustered indexes exist physically as copies of your table, and they must be kept up to date too. So thus there's an overhead cost with every write operation. However, it's not as straightforward as that. Your writes could actually benefit. Your queries that do a lot of writing could actually benefit because the source of the writes is benefiting from non-clustered indexes. So it's not enough just to say, no, I don't have any non-clustered indexes in my database because I want my writes to be fast. That is not a nuanced look at really what non-clustered indexes provide. Indexes should be created to help many queries at a time with many suggestions. So what I'm getting at here is that you don't create an index just for one query. It better be one damn important query for a damn important person for a single query to get its own index. Often you want to look at missing indexes views to see if there's any other passively collected index recommendations that either overlap or can be combined with that one super important index, right? You want to combine suggestions together with common key columns in the same order, the same starting order specifically, and you can combine includeds list, and the order of the includes list of columns does not matter. Combine your existing indexes on the table as well. So right before you go and create that new index that you have shaped together by pushing together all these missing index suggestions, be sure that you look at the existing indexes as well. You may be able to replace an older index. However, be careful not to change the uniqueness of a table. So for example, I would never drop and replace a unique index, a unique constraint, same thing, with a new missing indexes stuff. That's just going to have to be two different indexes because I don't want to change the programming of the database. But otherwise, adding non-unique, non-clustered indexes is very safe inside, and it requires no code changes inside a database. So when do you start looking at, oh, I wanted to mention one more thing. Talking about combining existing indexes, there's a pattern out there that a lot of developers and a lot of DBAs have taken to index all the foreign key columns, right? So all the child columns in the foreign key table. And you put an index just on that one column for the foreign key, and that may help as it's traversing foreign keys in a join, for example. And that's not wrong guidance to start there. But that doesn't mean that that foreign key index can't be replaced by another index that starts with that same column, but also has other columns and includes other columns as well. You still get the same benefits when you're traversing that foreign key. So starting with indexes on foreign keys is a fine starting place, but that doesn't mean that those indexes are golden and protected and they don't change. No, you can replace them as long as they're non-unique with another index that contains more information. It's actually pretty rare. It only really happens in joins that you will only ever query a table for one column, right? So having a one column index is very rarely helpful. Use missing indexes to come up with more columns to add to that one column index. So when to use? After recording actual usage in production, and that's important because you shouldn't really do this during development. It might be misleading because, well, developing is happening. Do use during your user testing maybe to simulate actual usage. That may be valuable missing indexes data to take into consideration. And you do want to use it in your production environment after a stable period of time. Try to capture a whole business cycle, weekly payroll, month-end reporting, quarterly or annual reporting, or something like that, right? To get the most business usage into those indexes to make indexes that will serve the most queries. So final note on missing indexes views. Since 2008 in Management Studio, you've seen this green text that pops up above the execution plans. Do not create that index real clearly. Again, it must be one real important query to get its own index. Don't create that index. Take that as a signal to go look at missing indexes at aggregate and create an index like this one potentially that also contains suggestions and columns from suggestions for other queries to make one super powerful index to rule them all, right? Use this as an alert to go look at missing indexes, and there's a script here in the lab, in the toolbox you can use to look at missing indexes in aggregate. And then you combine all those together, you combine them with existing indexes, and then you go about creating non-clustered indexes. Moving on, index usage stats. So index usage stats tracks access operations on all indexes and heaps cumulatively. This data resets with the instance or if the database is detached, so be aware of that. Your database needs to be online for a while for this information to be useful. And it retains data even through maintenance operations. So you can join this to sys.indexes, a system table that contains all the indexes, an object ID and index ID, object ID being the table, index ID being the ID of the index in the table. So look for 0 values in the user lookups, user seeks, and user scans. Those 3 columns tell you about the read operations. Those columns tell you when the index has been beneficial from a reading standpoint. and then compare that to user updates. User updates tell you when the index was maintained. User updates tells you how many times you've paid the penalty for having that index in your table. Ideally, indexes should have very high values in the read column, higher than the user updates column, right? So this criteria could be different based on your intended table usage, but for sure, if you see 0 values in the user lookups, user seeks, and user scans columns, and millions of user updates for that index, you know you've paid the penalty for that index millions of times, and that index has not been used by queries before for beneficial purposes, right? And so then you could drop that index, which is why I led with the caveat that you really need to make sure that this has captured a good amount of your business cycle. Don't go dropping indexes that are only used once a month for critical, business critical reporting at the end of the month, right? So make sure that you're tracking this data. You can maintain this data outside in a regular table. If you know you're about to reboot, you don't want to lose this data, because you need to make sure you're capturing that business cycle and only dropping an index if you are absolutely certain that the entire business cycle is not relying on that index for some sort of reporting, right? But again, only use it after stable period of actual production usage. And there's a query right there in the toolbox for you to go and check this out on your production databases today. So just to recap about indexes: physical stats, check for fragmentation; missing indexes, check for new indexes, help you design new indexes; index usage stats help you evaluate existing index usage. All right, how are we doing on time? We're doing great. All right, rapid fire round begins. Only got a few more minutes of just one-page DMVs just to tell you about some really cool stuff that's going on, including some new ones. So SysDM OS performance counters. You can query perfmon stats from within SQL without having to write WSQL, the WMI querying language. So this replaces the deprecated sys.sysperfinfo, and it does a lot better job. It includes hundreds of all the perfmon counters that you would see in Windows Performance Monitor that begin with the SQL Server : instance name, blah, 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 blah. This even works in Linux. So you can get the SQL Server metrics out of this DMV in Linux without having to go to any of the other Linux tools for something like that. This is slightly more involved, though, to read the values out of this DMV than out of perfmon. So for example, buffer cache hit ratio is a relatively useful memory usage counter. It's not a perfect number. It's not even a preferred number by some folks. There's better numbers like page life expectancy out there, which you can also get through this DMV. But to get buffer cache hit ratio, you actually need to do some division between 2 different rows that show up in this DMV, and that gives you the ratio that is otherwise returned as 0 to 100 in perfmon. So just be aware of that. And I've got a script that just demonstrates that. DMOS performance counter shows you how to get the buffer cache hit ratio. Page life expectancy, that SQL in our toolbox, we use it all the time, uses the same thing to get the PLE out of the SQL Server instance. The same thing that you would see in perfmon. SysDM OS sys memory includes the total and available memory, physical memory, and the cache levels, and the current page life expectancy, and much more memory-related data as a current snapshot. It also includes this really cool thing, this old signal that's always been in there in Windows. It has flags for high or low memory from Windows. So your application could query this DMV. Again, it would not require sysadmin tools or anything like that to query this DMV. Your application could query this DMV to be able to automatically scale itself up or down based on a low memory or high memory signal coming from Windows. And that's all based on the available server memory. Still in rapid fire. I got 2 slides in there. Still in the rapid fire mode. SysDM OS host info. This host information includes version information for both Windows and Linux. And because it's for Linux, it actually replaces an old DMV, SysDM OS Windows info. And it works for both Windows and Linux. And some screenshots there I pulled from a blog literally 30 minutes before this presentation because I thought that was cool. But it can tell you what operating system you're on. Otherwise, it's kind of hard to tell. SQL on Linux and SQL on Windows are pretty identical from inside SQL Server. SysDM server services, it shows you the service information, including the last time the service was started, whether or not the SQL agent is running, and since SQL Server 2016 Service Pack 1, whether or not instant file initialization is enabled. And I know that's something that's in my health check. Anytime I'm looking at a SQL Server for the first time, I want to make sure IFI is on. This is another example of a change to a DMV that was pushed to a lower version of SQL Server via a service pack. So for example, SQL 2012 did not have this column, but SQL 2012's SP4 got this column added to it. SysDM Server Registry contains a lot of registry information. You can query the registry for SQL Server folders and keys from inside SQL Server, including, for example, these are the things that you put in SQL Server Configuration Manager. The only thing you pass to the SQL Server executable when it starts up are those values in the SQL Server Configuration Manager startup flags. UI in that tab, and you can see the location of the error log, the master database, and the master database log. You can actually see that from within inside SQL Server. Is that super useful? No. Is that cool? Definitely. Would that be my superpower? No. But is it cool? Definitely. SysDM OS volume stats bypasses WMI calls, something you had to do before to get, for example, how much space is left on this volume. To get the physical drive size and available space from within inside SQL Server. Then you can join that to sysmaster files and you can see, okay, I've got a log file growing right here, how much space is left in that volume. Only caveat is that it only shows volumes for where a SQL Server file is present. So if you have other volumes on the SQL Server that don't have SQL files on them, you actually can't monitor them with this DMV. You'd have to fall back to the old XP fixed drives to see something like that. And there's some scripts right there. You can do that too. And the job you could set up to send you an alert. Failing any other kind of enterprise monitoring tool that monitors for volume stats, or maybe you just don't trust the folks in the sysadmin team and you want to know if your SQL Server volumes are about to fill up, you could do that kind of monitoring yourself, all from within SQL Server. A couple more. SysDM log stats. This is new for SQL 2016 Service Pack 2, and it was introduced in 2017. This is a handy DBA-friendly one-stop shop dashboard for the transaction log, including getting your virtual log file size and counts out of the log, log reuse reason, the backups information, and this use this instead of the old DBCC log info. So if you have any old queries that are based on DBCC log info, you don't have to dump those into a temp table anymore. You can actually just query them and join them out of SysDM DB log stats. And then SysDM IO virtual file stats. This includes an ascending counter that can be used to measure the data volume over intervals. This would tell you all sorts of IO information about your various volumes. So you could say to your storage admin, hey, the F drive, the stalls and the latency on the F drive are really high. Could you do something about that? This also might help you move SQL files around to spread out that IO workload and avoid that conversation with the storage admin, right? So there's a script here in the toolbox where you could record the file stats over time, use those ascending counters to figure out how much activity is actually going on in each of your volumes. And again, it's always a good idea to break out your SQL Server files and folders into different volumes, not have everything on the C drive. I'm saying that for the developers in the room. I know you DBAs know better. SysDM OS ring buffers, access to ring buffer endpoints of extended event sessions from within this DMV. This includes the built-in extended event session for system health, which ships by default with SQL Server. That is already gathering a lot of data, including a history of CPU and memory utilization, including those high and low memory flags that I talked about earlier. It also is the only way to find a deadlock that you weren't looking for. So instead of having to set up a deadlock trace or that deadlock trace flag or anything like that, you can actually just look in the system health X event session, which has been in there for a decade now, to pull deadlocks that just happened out of the past. And you can pull them out of either the ring buffer destination or the Excel file, the XEL file for the extended event session. And you can get a deadlock report out of cache that you weren't prepared to catch before. Very, very handy for troubleshooting deadlocks. And there's a tool to pull deadlocks out of cache right then and there. Now it is a rolling cache. The ring buffer is obviously a rolling amount of memory, so it's not going to have a complete history of all deadlocks. It's only going to have recent deadlocks. And then SysDM HADR cluster, talking about availability groups now. And by the way, it's not an always-on cluster. That's a marketing term. It's not a DAG. That's an exchange term. It's availability groups. Just please say availability groups. It doesn't matter if it's the secondary or the primary replica, but many of these DMVs do require you to run on the current primary replica. This will still work, you just won't get all the information back if you run it on the secondary replica of an availability group. And then you can use DMHADR cluster members to see the members of an availability group as well. And you can create your own monitoring tools for a performance snapshot of availability groups, including all the current configuration, the endpoints, what's secondary, what's sync, what's async, what's automatic, what's manual failover, including all your current RPO and RTO measurements as well. So that's your recovery point objective and your recovery time objective. So how far behind are your secondary replicas and how much time is it going to take them to get caught up? This is especially useful for asynchronous replicas. You're going to want to monitor this to make sure that you can keep up. And it's going to show you the last commit time. You can see exactly when and how far back a secondary replica has been caught up with the primary. So in the lab, there's an AG monitor script that gives you a snapshot. It actually takes a 10-second wait for in there just to kind of give you a snapshot of recent 10-second activity for the churn of the log and things like that in order to measure RPO and RTO. Super handy just for monitoring your availability groups and way better than what's built into Management Studio. You could do all that with the DMVs that they provide for you. And last one, I believe, SysDM DB page info. This is new in SQL 2019. It replaces most of the use for DBCC page. This is a little convoluted if you're not used to dealing with DBCC page. There's no need to turn on that trace flag anymore. This is a DMF. It can be joined to other DMOs. If you're trying to figure out exactly what's inside of a page, or perhaps when you find something waiting on something else and it's a page resource, you could figure out exactly what it is that's waiting on. Maybe that might be helpful from a troubleshooting standpoint. But it actually doesn't help you with all the different types of wait resources. It only helps you for page resources, wait resources, not for key wait resources, so it is limited. It is pretty cool though, and if you have some more esoteric uses for DBCC page, you might want to consider using this new DMV that is going to be introduced in SQL 2019, coming out quarter-ish. Here's helpful links, sources, and continued reading, certainly stuff that I use to learn from in order to build this presentation over the past decade. Here's a book I wrote for Microsoft, came a couple years ago. We are currently working on the next one. We expect it to come out quarter-4-ish of this year. Information about me, there's my blog. I'm going to post all these slides and all the sample stuff and all the links to all the toolbox scripts in that blog post right there.